This is the first video regarding to Centum CS3000 from Yokogawa. In this video, we make a quick project, and in this project we try to create a simple PID application, and we simulate that. To create a project, you need to click on System View, provide some project information, and accept the default settings with clicking on OK. The next step is to select the FCS as the PLC to perform or execute the logic. For this example, we select AFV10D, Duplex Field Control Unit. Next, we select the HIS with station number 64. In the FCS, we need to add a new node. The first node is considered local. In the node, we can add extra module such as analog input and analog output in slot number 1 and 2. First, we add the analog input, and we add a label to first channel. It's similar to a symbol in other PLCs. After adding label, you need to save it. The next module is analog output, and it will be on slot number 2. First, the type of module should be selected, and then the channels should be labeled. Save the changes without an error or warning. The next step is to add logic to the function block folder in the FCS. Search for PID. And give a tag to the PID block TCV5001. The next block that we need is the PIO for the input-output connection. Add the label for the analog output here. And similar label for the output signal. In this example, the value in analog output is fed to the input of the PID controller. For successful connection between the blocks, you need to select the starting point and double click on the end point, as you can see. As function block is compiled without any error or warning, we go to the next step, that is starting the test function to simulate the whole program and the hardware. We need to open the wiring editor, and we need to perform the automatic wiring. So select the automatic wiring and search for the PID and the name tab. Put PID in automatic with the set value of 50 and test the output. As you can see, PV is reaching to the set point value. The next step is changing set value from 50 to 70. In this part, simulation is done successfully. The process value is reaching to the set value very easily with the selected P and I parameters. In the second section, we try to make a different setup in our logic and in the simulation layout. In logic, we use the actual analog input and analog output for input and output of the PID controller. And then in simulation, in the test function window, we write the wiring manually to create a process that converts the output in analog output in analog output to the value in analog input with some parameters, selectable parameters. For this purpose, we need to delete the old inputs to PID controller, add new PIO, and we also need to provide the actual or physical addresses for analog input and analog output to the input and output of the block. This is for the analog input module. We need to type the actual address. This is the address for analog input. Same thing should be done for the analog output address. Provide the address for analog output. And do the connections as the next step. There's no error or warning for this program. Next, we need to define the manual wiring in the wiring editor. In to-terminal, we need to provide the analog input address, and the from terminal we need to provide the analog output address. The wiring type is analog direct. Gain is 2. no bias, and delay is 1, and lag is 20. We need to download the wiring. Now we can test the PID controller and see the result. TCV 5001. The PV is negative, so we need to put the controller in automatic mode and change the set value to 30. So PID controller is functioning as we expected. It's possible to change gain and integration time. In order to have a good view of dynamic action of controller, we prefer to add some trend points to log data with a better precision. For that, we need to add some points in trend acquisition pen assignment builder. All signals should be filled here. The PV, SV, and MV. Save the result. And eventually we need to add trend and provide all pen elements in that. Pen assignment. Use pen assignment to provide the labels for signal that you need to log those data. Provide the upper and lower limits. So all data are logged, then you can see the result in this trend. For a better view, I call the PID controller again and change the set value from 30 to 80 and see the result. This type of data logging is a permanent data logging, and in future you can have the access to log the data for future analysis.